Hi everybody, today we are working on 6.6 day 3. We are solving equations with extraneous solutions. Your essential question says, how can you determine if a solution is extraneous? An extraneous solution is a solution that doesn't work. It's an extra one. I think we've seen these earlier this year at some point. Essentially, it's an equation where you plug it into whatever you started with, and like it breaks your equation. It doesn't work when you plug it in. All right, we're going to talk about some steps, I think, and then do a bunch of examples for you. All right, you have 5 steps when you're solving with extraneous solutions. The first part is like very similar to what we did last week. So check the bases of the logs. Check to see if the bases of the logs are the same. If they're the same, set whatever was after the log or natural log equal to each other. Then you move everything to one side of your equation. You're going to solve for x using the x method or slide and divide. So essentially you're going to have to factor. We want all of our final answers to look like this. There'll be 2 sets of things. We'll review slide and divide and x method here as we go through the problems. The last part is plug the x's back into your original equation. Now here's kind of the unfortunate part of these problems is they're not short because you have to slide and divide or you have to use the x method, but then you also have to plug it back into your answer. So they are a little longer. I do recommend that you show all your work. That way if you're stuck, you can send me or Miss Schwann's a picture of what you've tried, and so we can help you figure out what you did wrong. Honestly, I think that's the best way for us to help you. So again, show all your work on a piece of paper. If you're stuck, your homework didn't go well, send us a photo of it and we can help you out. All right, if you haven't written this down or you need to take a picture of it or whatever you're doing, do that and then move on. All right, our first problem, we have the natural log of x squared minus 16 equals the natural log of 6x. Now remember, our first step was to make sure that we had the same base. Notice this one has a natural log and this one has a natural log. Since those are the same, we can just set whatever's in the parentheses equal. So we're going to do x squared minus 16 equals 6x. Now at this point, it just becomes a algebra problem like we've been doing all year. So I need to move everything to the left side, well, maybe not the left, but all needs to be on the same side. So I'm going to go ahead and subtract 6x from both sides. When I do that, we get x squared minus 6x, let's put that one in the middle, minus 16 equals 0. Now at this point, to solve that equation, I have to do slide or divide, or I have to do the x method. Remember, you do the x method when there's a sneaky little 1 out here. So I'm going to draw my x. We are looking for something that multiplies to that last number, so multiplies to negative 16, and adds to the second one, negative 6. So what can I multiply to get 16 and add to get negative 6? Well, I know that 16 is the same as 8 times 2. And if I want to get negative 6, that 8 is going to have to be negative, because negative 8 times 2 gives me negative 16. Negative 8 plus 2 gives me a negative 6. That means I can break down my equation. So I have x minus 8 times x plus 2 equals 0. Remember, from here, you're going to set each of those equations equal to 0. So I have x minus 8 equals 0 and x plus 2 equals 0. And then we're just solving for x. So I'm going to add 8 to both sides. I get x equals 8. I'm going to subtract 2 from both sides, and I get x equals negative 2. Now here are my 2 solutions. I need to figure out if one of these is extraneous, so I have to figure out if they actually work. We're going to plug them back into our original equation. I'm going to change this color here. So I'm going to do the natural log of 8 squared minus 16 equals the natural log of 6 times 8. Ooh, I'm out of room. So we have the natural log of 64 minus 16 equals the natural log of 6 times 8, which is 48. Again, we're going to simplify 64 minus 16, and that gets me 48. So I have the natural log of 48 equals the natural log of 48. Now this is perfect because those 2 things are equal, so that one works. That means that x equals 8 is definitely a solution. Now, I still have to go back and check x equals -2. So I'm going to zoom out a little bit so I have some space to do that. And let's pick a different color. We'll do green. All right, so my next one, we're going to do the natural log of -2 squared. Oh, that's not going to be enough space. Let's do it down here. Natural log of -2 squared minus 16 equals the natural log of 6 times -2. There's in theory an extra parenthesis there, but again, space. All right, if I square -2, you're actually doing -2 times -2. So you get a positive 4. So I'd have the natural log of 4 minus 16 equals the natural log of 6 times -2 gives me a -12. If I do 4 minus 16, I get the natural log of -12 equals the natural log of -12, and those two things are in fact equal. Now, here's my problem. I can't actually take the natural log of a negative number. So even though those are equal, if I plug it into my calculator, if I do the natural log of -12, it'll say no real answer. Which means that this one actually is extraneous because it doesn't work. So if you get a negative number inside your natural log, that one will not work. That means that for this problem, our one and only answer is x equals 8. All right, we're going to go ahead and move on to the next one. All right, we have log base 5 of x squared minus 45 equals log base 5 of 4x. Again, since these are both the same, we can just set the other stuff equal. So we're going to do x squared minus 45 equals 4x. Again, I want to move that 4x to the left side, so I'm going to subtract 4x from both sides. And we get x squared minus 4x minus 45 equals 0. Again, at this point, I'm going to set up my x method. We're looking for something that multiplies to c, which is -45. Again, multiplies to c, adds to b, and adds to that second number, so adds to -4. So what can I get to multiply to -45, add to -4? Well, I know 4 and 5, if I multiply those, I get 45. And then if I make 9 negative, I can do -9 plus 5 gives me -4. So that means my two factors are x minus 9 and x plus 5 equals 0. Again, we're going to set both of those equal to 0. So x minus 9 equals 0, x plus 5 equals 0. And we're going to solve for x. So we're going to add 9 to both sides. X equals 9. And we're going to subtract 5 from both sides and get x equals -5. Again, we are going to go ahead and plug these into our equations and hope that they work out nice. So again, I used that original equation. So we're going to do log base 5 of 9 squared minus 45 equals log base 5 of 4 times 9. So I have log base 5 of 81 minus 45 equals log base 5 of 4 times 9 is 36, yeah? Yeah. All right, so then if I do 81 minus 45, I get 36. At this point, we have log base 5 of 36 equals log base 5 of 36. Those two are equal. So that means x equals 9 is in fact an answer. All right, we are going to go ahead and check the last one. And then we'll move on to a new problem. Yay! I know you just get so excited. Wow, what did I do there? I'm just going to shrink it a lot so I have room. Okay, so my last one, oh, I almost tried to write with a real pen. We're going to do log base 5 of negative 5 squared minus 45. Sorry, I keep trying to write it over there and there's just not enough space. Okay, log base 5 of negative 5 squared minus 45 equals log base 5 of 4 times negative 5. Okay, if I square negative 5, I get 25. So we have log base 5 of 25 minus 45 equals log base 5 of negative 20. All right, 25 minus 45 gives me a negative 20. So really I have log base 5 of negative 20 equals log base 5 of negative 20. Again, we can't take the log of a negative number. It won't give us a real answer. So since we end up with a, negative 20 here and a negative number there, this final answer, x equals negative 5, will not work. It is important that you check it because the equations inside might end up giving you a positive number even though your original x was negative. But for this one, our final answer is just x equals 9. All right, our last example, we have the natural log of negative 4x minus 1 equals the natural log of 4x squared. Now again, notice that we have natural log and a natural log, they match, so we can just write negative 4x minus 1 equals 4x squared. Now at this point, I need to move everything to one side. I like to have my number in front of 4, or in front of x squared positive, so I'm going to go ahead and add 4x and add 1 to both sides. When I do this, this gives me 0 equals 4x squared plus 4x plus 1. Now this problem is different from the rest of our problems because we have a 4, we have a number in front of our x squared. So we're going to have to use slide and divide. Remember, you take the 4 and you slide it to the 1 and you multiply. So you get x squared plus 4x plus, we did 4 times 1, is 4. At this point, you can go ahead and set up your little x method. We're looking for something that multiplies to your last number and adds to the second one. The second one's a 4. So we're looking for something that multiplies to 4 and adds to 4. Our options are really just going to be 2 and 2. But before we put it back in our equation, remember you have to divide by whatever you slid. So I'm going to go ahead and divide by 4, and then you need to simplify your fractions. So I can divide the top and the bottom by 2. So I'm going to go ahead and do that, and I get 1/2. Same thing over here, divide by 2, divide by 2. This equals 1/2. That means that my two factors are x plus 1/2 and x plus 1/2. Notice they're both the same. So when I solve, I don't have to solve them both. You can just solve one because you'll get the same answer. So I know x plus 1 over 2. Oh, actually, before we even go that far, we don't want a 1/2 on the bottom. Remember, you have to move that 2 so it's in front of your x. So this is really 2x plus 1 times 2x plus 1. That other thing I said about just solving for 1 is still true. So we're going to do 2x plus 1 equals 0. We'll go ahead and subtract 1 from both sides. When I do that, I get 2x equals negative 1. We'll divide both sides by 2. And we get x equals negative 1 over 2. Now again, I could go ahead and take this equation, set it equal to 0, but it is the exact same thing, so I'll get the same answer. At this point, we need to go ahead and plug our answer back into our original equation. So we're going to have the natural log of negative 4 times negative 1/2 minus 1 equals the natural log of 4 times 1/2 squared. If I simplify, we'll have the natural log of negative 4 times negative 1/2 would just be 2. So 2 minus 1 equals the natural log of 4 times. If I square 1/2, I have to square, oh, it's a negative 1/2. So it should be a negative sign. We square the top and we square the bottom. We get a positive 1/4. And then if we simplify a little bit more, we'd have the natural log of 2 minus 1 gives me 1. And the natural log of 4 times 1/4, which is also just 1. So we'd have the natural log of 1. These two are equal to each other, so they do in fact work. That means that x equals negative 1/2 is our solution. You don't have to write it twice. It does show up twice, but you can just write it once. I guess in this case, that second one is sort of like your extraneous solution because it's just the same as the first. It does work though, so x equals negative 1/2. Alrighty. Thank you for watching. I'm sorry this video was kind of long. Again, if you have questions about your homework, please send us a picture of the work you've done, and we can go ahead and figure out how to help you.